Hello there. Thanks for joining us on today's webinar. We'll give it a few seconds for everyone to join, and in the meantime, feel free to familiarize yourself with the controls, and if you have any questions, please submit them for Q&A. We'll try to get those questions at the end today, so I guess we should just dig into CloudArmour. This is Hillstone's cloud workload protection platform, and we're going to dive into securing cloud workloads. CloudArmour stands out due to its unparalleled ability to cater to the past, present, and future of application development. In the past, monolithic architectures were the norm, particularly in early-stage development. These architectures, though tightly coupled, offered advantages such as ease of development, debugging, and testing. Additionally, they were cost-effective. However, the need to deviate from this structure arises from the fact that monolithic application development lacks elasticity and agility. Presently, applications are becoming increasingly complex, and business operations rely heavily on them. In the future, this trend will only continue, which is why a cloud workload protection platform like CloudArmour is needed to support the past, present, and future. So we've identified 5 main challenges. New capabilities mean new vulnerabilities. As new capabilities emerge, so do vulnerabilities in cloud workloads. Configuration compliance. Managing configuration compliance for cloud workloads is challenging due to the diverse nature of cloud environments, complex configuration options, rapid changes, potential shadow IT, misconfiguration risks, visibility issues, automation complexities, and the list goes on. Lateral movements. Detecting lateral movements among workloads is challenging due to the sheer volume of workloads spanning the expansive cloud landscape. Cloud workloads can exist across a large variety of clouds, such as private, public, multi-cloud, etc. To use our own product as an example, CloudHive can provide micro-segmentation across VMs, but when it comes to containers, there are different configurations needed, as containers operate differently from VMs. Intrusion prevention. More applications are being developed as containers, which are deployed and retired at a much faster rate, so it can be difficult to manage them and difficult to run intrusion prevention. A centralized view across the workloads that could automatically be deployed as the workloads are expanding and shrinking would be much more efficient than trying to monitor on a case-by-case basis. We need a solution that can fit with a continuous deployment model. And finally, with different types of cloud environments, not only do the types of protection need to expand, the ability to manage this inflated number of protection schemes needs to improve significantly. For starters, with vulnerabilities on the host and software, there exist privilege escalation vulnerabilities in Windows and Linux. In Linux, attacks begin when attackers initiate enumeration. Through enumeration, attackers will interact with systems to learn more about the software components, retrieve data from key system directories, and see how the system responds in certain inputs. After enumeration, 2 common methods of exploits are sudo or exploiting the kernel. Sudo is a Linux command that allows users to run programs using system admin security privileges. Instead of directly looking to gain root privileges, which would be exploiting the kernel, attackers could try to compromise a user that has sudo privileges and then horizontally or vertically escalate privileges from there. Kernel exploits. Every once in a while, new vulnerabilities are discovered on the Linux system, and attackers will utilize those vulnerabilities to gain root access to a Linux system, also known as exploiting the kernel. Kernel exploits can be quite detrimental because the kernel tends to contain key functions. If those key functions are compromised, the whole system will be in peril. Middleware is a key innovation that enables the transition of legacy monolithic applications into cloud-native applications. Microservices scale a lot better than the traditional monolithic architectures. A simple phrase to remember here, what middleware does and why it's so important is, with middleware, you can build something here in location A, then deploy it in location B, and it will all still work. It provides common services to applications that may not necessarily be provided by the operating system that an application is trying to run on. The next genre of host security challenges is ensuring the environment configurations are compliant. Open ports by themselves aren't necessarily bad, but if ports are left open and the network and security configurations are not compliant, then these open ports become points of vulnerability that can be exploited. Other examples of improper environment configurations are improper authorizations being assigned to certain users, or even the simple weak password trope where passwords are not up to a certain standard and are easy to exploit. Moving on to intrusion detection difficulty. A reverse shell exploitation is common, and it is when an attacking machine is able to coerce a target machine into initiating a connection with an attacking machine. A detailed example is as follows. The attacking machine exists outside of the network, the secure network, and the target machine exists within the secure network that is protected by a firewall. Normally, on an attacking machine, we would want to open a shell on our target machine to compromise it and gain remote access. However, in this scenario described, because the target machine exists within a secure network that is protected by a firewall, we, as the attacking machine existing outside the secure network, will not be able to initiate a connection with the secured target machine. However, because a firewall usually only stops inbound traffic and does not stop outbound traffic, we could potentially compromise the target machine if we can get the target machine to initiate the connection with us, the attacking machine. But how would we do that? This is what a reverse shell is. To start, on the attacking machine, instead of trying to initiate a connection, we would instead open up a listening port, waiting for any connections that may come our way. Then, we would want to find a way to send a malicious script, for example, via phishing email to the target machine. If the target machine is able to open up the phishing email and execute the malicious code, the machine will initiate an outbound connection on the same port that the attacking machine we established earlier is listening on. From there, once the connection is established, the attacking machine now has control over the target machine. In light of cryptocurrency becoming more and more popular, there's also the risk of cryptojacking, which is where crypto miners install malware on unsuspecting devices and utilize a device's processing power to illegally and stealthily farm for cryptocurrency. This form of intrusion can be difficult to detect because it is often done via a remote server, meaning the crypto miners can alter their code to bypass security measures. And finally, there's the risk of lateral movement. As east-west traffic grows, the potential for attacks also increases. Once an attacker gains access to a single asset, they can potentially move laterally to other assets through east-west traffic. This lateral movement can allow the attacker to explore and exploit vulnerabilities within the network, potentially leading to breaches or security incidents. From the container side, container images are a large point of vulnerability for individual containers. Specifically, if a container is created based on a vulnerable container image, then the vulnerability will now be live and able to be exploited. Container scanning is available to check for vulnerabilities, but one limitation to it is that it can only halt known vulnerabilities that have already been discovered. Unknown threats generally can't be stopped with scanning. Having runtime security that can activate after the container is running will be crucial for halting unknown vulnerabilities. As it pertains to the infrastructure of containers itself, there are a lot of different compliance standards that it needs to adhere to. This happens because containers often use more open source components, and it accelerates the software development process, which unfortunately results in typical security checkpoints occasionally being ignored. Additionally, some of the new vulnerabilities that are introduced by container solutions may not necessarily be compatible with an older version's configuration management processes. So moving on, there are various vulnerabilities we could classify as runtime vulnerabilities. Runtime is the actual engine that runs a container, whereas something like Kubernetes is the management system that orchestrates it all. The first runtime risk is a container escape. Normally, a host's operating system provides a barrier of isolation between the host and the container. But, like the name suggests, a container escape is where a containerized application's vulnerabilities can be exploited so that a malicious attacker breaks past the isolation boundary and attacks the host's system's resources directly. From there, the malicious attacker can potentially leverage privilege escalation tactics to gain control over the whole system. Finally, we'll move to the network side. In Kubernetes clusters, there does not exist a default security policy for the network. This, mixed in with the popularity of lateral attacks in containers, is why the network with Kubernetes can be a huge point of vulnerability. So as you can see, the majority of vulnerabilities still rest in the runtime segment of the container, and that is where many of the unknown threats will lie. Threats are generally divided up into three stages: the development and packaging stage, the image management stage, and the runtime stage. Development and packaging encompass more of the pre-planning and the creation of the system, that is, how strong of an isolated boundary is going to be created between the host and the container. During the image management section, this is where image templates could be infected. When a container is running, the images being used could potentially be vulnerable, especially those that are publicly available. During runtime, when the container is actually running and services are being provided, there's a whole suite of vulnerabilities that exist, as we discussed earlier. Now, in order for container security to be able to tackle all the challenge listed in the previous slides and be able to fit into the lifecycle stages, we have this graphic, a master template of sorts, and we like to adhere to it. Towards the left, which is earlier in the lifecycle, there are more static approaches we can take. After all, at this stage, things are still in development. So during that development process, we can insert forms of security that will be helpful later on in the lifecycle. Examples of security we can implement are code analysis, which is essentially careful reviews and considerations when building the code, and taking precautions when packaging the images and pre-scanning them. Moving on to the image management section of the lifecycle, some forms of security that could be implemented are image scanning and enabling the idea of trusted images. The idea of trusted images is similar to whitelisting. Finally, to the runtime section of the lifecycle. This section is segmented into two subsections, part of which is static security and part of which is dynamic security that'll need to adapt on the fly. During runtime, there are known and unknown vulnerabilities that need to be accounted for. There is an increase in vulnerabilities that exist in cloud workloads from traditional bare metal and VM-based servers to the more modernized container-based and in-public, private, multi-cloud, and hybrid cloud environments. As such, there is an increased need for security and risk management, not just on the development side of things, but also on the runtime side of things. CloudArmour can provide comprehensive visibility on cloud-native workloads and applications, and it integrates vulnerability management and compliance across the entire lifecycle of applications. This will ultimately help organizations meet the security demands of new cloud infrastructure architecture as well as the rapid evolution of DevOps. CloudArmour boasts two integral components that contribute to its exceptional capabilities. The first is the CloudArmour Control Center, which operates as the centralized management hub. This serves as the nucleus of the system, offering comprehensive, centralized management functionalities. Within this hub, users gain access to an array of tools, including a security posture dashboard, monitoring utilities, policy enforcement configurations, alert systems, asset management functionalities, threat detection mechanisms, vulnerability assessments, compliance evaluations, and much more. Now, transitioning to the second component, the security guard. This formidable component is deployed within each workload, acting as a vigilant guardian. Its primary responsibility is to diligently oversee individual workloads, providing vital insights and information. This includes conducting tasks such as virus scanning, as well as facilitating event and information reporting back to the control center. The synergy between these two components is paramount. Users will predominantly monitor operations through the CloudArmour Control Center, thereby achieving a comprehensive overview of all assets, traffic flows, status of critical components, and other pertinent details. Hillstone CloudArmour encompasses a robust array of features designed to bolster your security landscape. These include extensive micro-segmentation, advanced intrusion detection and prevention, runtime behavioral modeling and protection, antivirus functionality, security compliance checks, vulnerability and weak password scanning, and comprehensive visibility via a full-screen dashboard. These dynamic components collaborate harmoniously, culminating in a holistic and sophisticated security solution. Now, in the coming slides, we'll dive deeper into each of these components, providing an in-depth exploration of their functionality and benefits. As mentioned earlier, CloudArmour can monitor both the host and container security on a granular level via a dashboard view, be it bare metal, VM-based, container-based, and the like. This comprehensive dashboard is able to display granular details, allowing for real-time assets management and unified workload monitoring. Real-time asset management is a key component of CloudArmour's central management capabilities. It allows CloudArmour to sync up with the host and image assets, including data involving images, apps, services, and clusters, along with information from the host side, such as the operating system, network cards, and other processes. Now, over to the unified workload monitoring. CloudArmour allows for this by possessing a full-screen dashboard which can display both the host and container assets. The dashboard displays intricate details on the cloud environment status, vulnerability information, traffic information, intrusion events, virus detection, compliance statistics, and other specifics. All this information allows for a thorough understanding of the cloud environment's current security posture. As a cloud workload protection platform, CloudArmour is able to continuously monitor and scan for vulnerabilities in VMs, containers, hosts, bare metal servers, and others. It does this throughout the entire lifecycle, triggering alerts as necessary to mitigate risks before they turn into downright threats. For example, as it pertains to container security, vulnerability scanning and image scanning are run to ensure risks are noted and attended to before the application starts running. As far as weak password detection, CloudArmour excels in identifying weak password vulnerabilities across various domains, including Linux operating systems, database applications, web applications, and remote system management applications. It conducts comprehensive scans of configuration files, examining plain text passwords and matching encrypted hashes. In addition, customization lies at the heart of weak password detection, empowering users to personalize weak password dictionaries according to their requirements. Now, in terms of compliance, CloudArmour follows the CIS benchmark guidelines and holds hosts and servers accountable, regardless of whether it's bare metal servers, containers, VMs, or others. Additionally, when it comes to these compliance risks, CloudArmour will provide a list of remediation recommendations, and it also provides compliant status, statistics, and trends, making it easy to grasp the overall compliance situation. Antivirus is a crucial component in a CWPP solution, as it provides a fundamental layer of defense against malware, and it helps maintain a secure and protected cloud computing environment. Recognizing this significance, CloudArmour extends support for virus scanning across both hosts and images. The CloudArmour antivirus scanning engine embodies a robust and real-time detection capability, ensuring protection against a diverse array of threats, including viruses, worms, Trojans, ransomware, spyware, and more. And it allows users to take immediate action on files that have been identified as infected with viruses. With a single click, users can initiate specific operations to handle or manage these files that are deemed to contain viruses. Our next capability of CloudArmour is a staple of our security products: runtime behavior modeling. System calls, file systems, network services, and others are all carefully monitored, be it containers, VMs, or bare metal servers. By leveraging its advanced threat detection, CloudArmour is able to stop threats based on behavior. This means a baseline of normal behavior is modeled and established. If behavior deviates too far from what is deemed normal, the system will generate alerts. Hillstone CloudArmour offers advanced intrusion prevention capabilities. By actively monitoring and blocking activities that pose potential risks, it effectively reduces the chances of runtime security risks. Among the prevalent threats it adeptly handles are anomalous logins, web shells, reverse shells, and attempts at escalated privileges. CloudArmour simplifies the identification of these prevalent threats while also offering detailed event information and effective incident handling options. Furthermore, it offers the flexibility of customizable intrusion attack detection, allowing tailored protection against evolving threat landscapes. The next key function of CloudArmour is its ability to allow for visibility into east-west traffic and protection against those types of lateral attacks. This micro-segmentation technology adheres to the concept of zero trust. CloudArmour performs micro-segmentation via industry-leading traffic steering technology coupled with policy matching. This micro-segmentation can effectively protect against traffic in all directions, north to south and east to west. Micro-segmentation enhances network visibility with granularity. By isolating and controlling communication flows between specific hosts or containers, security administrators can monitor communications between critical assets. This capability enables the swift identification of anomalies or suspicious activities. By being loosely coupled to a multitude of cloud platforms and workloads, CloudArmour is able to provide protection while adapting to rapid changes in the differing environments. Without components being directly related to each other, changes in one or problems in one will not affect another. This is a thorough solution that we'll see across all cloud workloads that an enterprise possesses. Effectively, the extensive micro-segmentation allows users to segment in the cloud, which keeps viruses under control and reduces other risks in the cloud. It helps regulate network access while providing an auditability of sorts where access and routes can be traced back to their origins. Additionally, alerts can be generated by abnormal behavior detection, and command and control and botnets can be mitigated. Let's touch briefly on some differentiating features of Hillstone's CloudArmour CWPP solution. First is the security posture insight. It's related to the all-inclusive dashboard in CloudArmour. As mentioned earlier, it displays clearly the traffic from the host and from the servers, regardless of the form factor they come in. Second is the policy assistant. It uses a 4-step process as listed here to monitor and analyze traffic data based on designated time and hit policy configurations. It then uses this analysis to build traffic models that represent how data moves within the network. With these models, the system can automatically generate micro-segmentation policies. This greatly improves the efficiency of policy configuration and management. Finally is the K8's admission control. This is the gatekeeper that safeguards your containerized applications from potential threats in the Kubernetes environment. This powerful feature addresses non-compliant configurations, vulnerabilities, and virus risks that may arise when organizations create or update pod resources within your Kubernetes cluster. In these last few minutes, let's quickly look at a few customer case studies. First, we have a huge bank in the finance industry with reported revenue of close to $30 billion US. In the Kubernetes cluster, in order to view the east-west traffic, the structure was set up where it first had to be translated into north-south traffic to the external hardware-based firewall before micro-segmentation could be leveraged. Now, naturally, this would prove to be rather inefficient. Because there would be some network delay during this cumbersome process, policy changes would put pressure on the management of the firewall. And to top it all off, workloads were really diverse, ranging from containers to bare metal to VMs, just adding to the complexity of the situation. Hillstone stepped in with CloudArmour because, first of all, as a cloud workload protection platform, it's able to account for the assets regardless of form factor. Additionally, CloudArmour could handle the east-west traffic internally, which reduced workload on the external hardware firewall. On top of this, the policy management process was greatly improved by implementation of CloudArmour's smart policy operations. This second case study pertains to an energy organization. For a state grid in the energy industry, when containers underwent source network address translation to go out to the internet, external firewalls would lose visibility of the source address. This was potentially a big liability. Additionally, the external firewall present had no east-west traffic visibility. Finally, the cluster was lacking runtime security control and did not possess any insight into abnormal application behavior. Hillstone stepped in with CloudArmour because it could help solve the pain points. CloudArmour's comprehensive north-south and east-west visibility, micro-segmentation, application and container behavior modeling, and other capabilities all came together to fix this one. Hillstone was able to implement zero-trust policies for this client by deploying CloudArmour. Okay, so it looks like we have a few questions that have come in, and in the last few minutes here, let's see if we can get to a few of them. So we have a question: how many nodes can Hillstone CWPP manage? It's a great question. Each Hillstone CloudArmour controller is capable of managing up to 5,000 nodes. Next question: does Hillstone CWPP have protective measures in place for business operations during periods of abnormal functioning. Yes, we have the bypass option wherein after a defined period of the security guards not being in their regular online state, Hillstone CloudArmour will automatically disable all security features. This approach ensures the uninterrupted flow of business operations. Let's see, another question. Can it handle situations where various administrators are responsible for different assets? Yes, so Hillstone CloudArmour offers a multi-tenancy capability that allows users to configure asset management scopes. This ensures that assets managed by different users remain concealed from one another. This functionality perfectly addresses scenarios where multiple administrators are tasked with distinct assets and free from any interference. Can Hillstone CWPP provide an API? Yes. CloudArmour is equipped with an API that facilitates integration with third-party devices and other Hillstone security solutions. It offers seamless access to crucial information for third-party platforms through API interfaces. It also integrates effortlessly with Hillstone iSource XDR solution, incorporating single sign-on support. So this simplifies the authentication process and paves the way for future integrations. Let's see, we got maybe time for one more. What is the license model for Hillstone CWPP? Our CloudArmour CWPP solution operates on a perpetual license basis. To get the system up and running effectively, you'll need two types of licenses, a controller license and a security guard license. The controller empowers you to manage and oversee the system's operations, and the security guard is deployed within each node, providing vital insights and information. Okay, well, we covered a lot, but thanks for sticking around. Of course, if you have any questions, feel free to call us or reach out to us using the information on the screen. Thanks very much for tuning in. We'll see you next time.